Hi everyone, my name is Janine Ko and I make educational videos like this. If you're interested in seeing more, you know what to do. Please subscribe to the channel, make sure to hit that notification bell, and give me a thumbs up. I'm pretty sure I've mentioned this so many times now that by the time you're watching this video, you would have known to apply direct substitution first before evaluating your limits. So in that case, if you look at number 9, we can actually plug in 0 into our x to see what we get. So we do have 1 over 0 minus 1 over 0 squared plus 0, and this results to infinity minus infinity. So the reason why this is infinity minus infinity to begin with is any number divided by 0 is actually undefined. So we've looked at factoring as a way to eliminate an indeterminate form. So in this case, for us to apply factoring first, it doesn't really make sense just because even if you were to factor the greatest common factor, so in this case, this would be 1 over x times x plus 1. This doesn't really help eliminate the indeterminate form just because it's still going to result to infinity minus infinity. So the best way to approach this problem is to actually combine the two terms together into a single fraction. So you would have to multiply 1 times x squared plus x, so this would result to x squared plus x in our numerator, multiplying both our denominator x times x squared plus x. And finally, because you have a subtraction symbol in between the two terms, you would have minus before you multiply x times 1, which is just going to be x. In this case, you see that x minus x is 0. So we get x squared over x, and this is times x squared plus x. Now this is the perfect time to actually factor out your x coming from this term. So first, before that, we can simplify x squared over x into just x. So we get x over x times x plus 1. Finally, we eliminate x over x, so this becomes 1 over x plus 1. So we see that we had to combine the two terms first before we had to apply factoring for us to eliminate this indeterminate form infinity minus infinity. Now we're ready to evaluate our limit when x approaches 0, and this is 1 over x plus 1. Therefore, applying direct substitution, we see that this is 1 over 0 plus 1, and hence this is 1. Our limit for number 9 is 1 when x approaches 0. Now moving on to number 10, as you notice, there's two terms again. So we have 1 over x minus 1 over 6. And as you recall, we actually had to combine the two terms together into a single fraction before we had to proceed and evaluate our limit. So in this case, the first thing you really have to do is combine 1 over x minus 1 over 6 into a single fraction. And I've mentioned this in my previous video about the butterfly method just because the way I combine the two fractions together, it looks like a stick butterfly, such that you had to multiply 1 times 6, so this becomes 6, and you multiply the denominator, this becomes 6x, and this is minus. So this is minus because you do have that operation symbol in between the two terms, and then you multiply x times 1, which is just going to be 6 minus x. So can you see this variation? It looks like a stick butterfly, so that's what I mentioned in my previous video. However, you are welcome to find the least common denominator. So it's really up to you to use whatever technique works best for you to combine the two terms into a single fraction. Now let's proceed to multiplying this to its reciprocal, which is 1 over x minus 6. Now we look at 6 minus x. Right off the bat, we can factor out negative 1, so this becomes negative bracket x minus 6 over 6x multiplied to 1 over x minus 6. And as a result, we are able to cancel out x minus 6 in both our numerator and our denominator. So we would yield negative 1 over 6x. And finally, this is the time to evaluate the limit when x approaches 6. So you would have negative 1 over 6x. Applying direct substitution, we get negative 1 over 6 times 6, and this becomes negative 1 over 36. And you're probably wondering, so first of all, why do we have to combine the two terms together into a single term? And the reason for that is because if you were to apply direct substitution in the first place, you would have 1 over 6 minus 1 over 6, and this is all over 6 minus 6. You actually get 0 over 0, and this is an indeterminate form. So that's why we had to combine everything into a single term, and then we see whether we're able to apply any technique to get rid of that indeterminate form. Now moving on to number 11, this is a little bit different just because we do have negative exponents as opposed to just seeing this in a form of a fraction. So what we can do here is see whether we do get an indeterminate form by applying direct substitution first. So we would have 4 plus 0, and this is raised to the power of negative 1 minus 4 raised to the power of negative 1, and this is all over 0. So we see that this is 1 over 4 minus 1 over 4, and this is all over 0. So we do get an indeterminate form, which is 0 over 0. So we need to eliminate this indeterminate form. And in that case, what we can do is rewrite 4 plus h raised to the power of negative 1 into a fraction. So this becomes 1 over 4 plus h. And on the other hand, we see that this is 4 raised to the power of negative 1. Therefore, this is minus 1 over 4. And this is all over h. So it looks similar to numbers 9 and 10, just because we need to combine this into a single term. So all we have to do is find the least common denominator and combine this into a single term first. So all we have to do is multiply 1 times 4, so this becomes 4. And then we multiply our denominator, which is going to be 4 times 4 plus h. And then we do have this subtraction symbol in between, so we would have to multiply 1 times 4 plus h. Make sure you distribute the negative sign into each of your terms. That's why it's important to have this bracket over here. And also don't forget, we still have that h over here in our denominator, so make sure you write the reciprocal in terms of 1 over h. And then we can simplify our terms. Therefore, we would have 4 minus 4, and this is minus h, so this becomes 0, and this is all over 4 times 4 plus h. Then you multiply this to 1 over h. So we do get negative h, or we can just cancel that out just by looking at h over here and h. And this is negative 1 over 4 times 4 plus h. So now, this time, we are able to evaluate the limit when h approaches 0. So we have limit when h approaches 0. And this is negative 1 over 4 times 4 plus h. We simply apply direct substitution by plugging in 0, so we would have negative 1 over 4 times 4 plus 0, so this results to negative 1 over 16, and hence our limit for number 11 is actually negative 1 over 16.